Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on binary tree level order traversal. This is a very frequently asked interview question. Let's jump into the problem statement, understand it and start solving. So last time we have solved the three-sum problem. You can find it in the list. Let's start with binary tree level order traversal. Okay. Given the root of a binary tree, return the level order traversal of its nodes values, that is from left to right, level by level. Okay, so let's understand this from example. We have this binary tree. You can see 3, 9, 20, 15, 7. And the level order traversal would be that we go one by one on each level. So first level is this one. We have only 3. 3 is in the output. Second level is this one, where 9 and 20 is there. And we have to go from left to right. So 9 and then 20. 9 and 20 is there. And then we have to go to third level, 15 and 7. 15 and 7. And likewise. Right. So before we move forward, please take a minute and think of an approach that you would use to solve this problem. Okay. So firstly, this is a very frequently asked interview question. It has been asked in a lot of interviews and it will still be asked in a lot of interviews coming forward as well. So what we need to do is, we can see that we can print 3 directly since we have the root. But in order to perform level order, we have the left child 9, we have the right child 20. So what we need is, we need somewhere to store these children. Okay. So first is we need to store this 3. We need to store the children, that is 9 and 20. Then one by one we have to pick the children, 9. And then look for children of 9, right? So we need to put them in a queue or list or anywhere such that we'll pick the children one by one. If they have children of their own, we'll add them to the queue. So that 9 will be picked up, 20 will be picked up, and with 20 we'll add 15 and 7 as its children. And then we'll move to next element in the queue, that would be 15 and then 7. It's it's actually very simple problem statement if you understand it. Let's code it. It will be really simple to understand and then we'll start solving it. Okay. So first let's say we have to return the answer in form of list of integers. Okay. Let's say we'll keep a result for this. Similarly, we would want to store the nodes, right? So we'll keep a queue for this. We'll keep a queue to store the values. And do we need anything else? We need another list to store the children. Okay. So we'll keep another list. Let's call it level nodes. Okay. So what we will do is, first we will directly add the root 3 to our queue. Okay, 3 is in the queue. Then we will check for 3. Since this is the only element on this level, we want in the solution that 3 should come like this. We would want that we store children of 3 separately. So in level node, first level node, 3 will come because 3 is there. And we'll save the children of 3 in the queue, 9 and 20. So we'll remove 3 from here. We'll save the children 9 and 20. One by one we'll perform this solution on 9. Okay, we'll refresh the level nodes. We'll perform the operation on 9. We'll add 9 to it. So 9 will remove 9 from the queue and we'll add 9 to level nodes. Then we'll check for children of 9. It has no children. We'll move to the next element in the queue. We'll check if the queue is empty or not. Next element is 20. We'll remove 20 from here. We'll add 20 here. We'll check if 20 has any children. If it has, we'll add it to the queue. So 20 has children, 15 and 7. They'll be added here. And then whatever is there in the level nodes, we'll remove it from here and add it directly to our result list. So result list will have 9 and 20. Similarly, it will refresh again. It will be 0. We'll pick up 15 next, and similarly we'll pick up 7. They'll be in the same level, they'll come in the same level node, and the final solution will be 9, 20, 15, 7. Okay, so let's start solving, and it will be much easier to understand that way. Ready? Okay, so what do we need first? First we need our result. So we'll say list of integer result is equal to new array list. Okay, we'll check for the base condition. What if the root is null in itself? So we'll check if the root is null. So if root is equal to null, we can simply say return result, which is null, right? Because right now there is nothing in the result list. Now we will create a queue for level order traversal. So queue of tree nodes. Tree nodes is this tree node. Oh, it's not nodes, it's node. Tree node. Queue is equal to new linked list. Okay, then we'll add the first root to it, queue dot offer. This is how we add elements to a queue, root. Okay, now let's start performing level order traversal. So perform level order traversal. So let's remove these values as of now. So in our queue we have added a root, so 3 is in our queue, right? Now we'll check for as long as our queue is non-empty, while not queue dot is empty. So until queue is non-empty, we'll keep performing. First let's find out the size. So with size we'll be able to figure out how many nodes are there at one level. So we'll say int level size is equal to queue dot size. Right now, since there is only one element 3, the size would be 1, right? Then we'll create another list, that is level node. Since we want to refresh it each time, we'll keep it as part of the loop. Integer level nodes is equal to new array list. Array list. Okay, now we'll process the nodes at the current level. Okay, so process nodes at the current level. Okay, so for int I equal to 0, I is less than level size I plus plus. So we'll check. Let's take out the first node. Tree node is equal to queue dot poll. So this 3 will be removed from here. It will be added to our node, right? Now we'll remove it from here and we'll add it to the level nodes. So we'll say level nodes dot add node dot value. Okay, why value is val? Because here the value is val variable. So we'll add the value of the node. We don't have to add the complete node, right? Our return type is in the form of list of integer, not list of tree node. That's why we're taking the value and we are adding it to the level nodes. So level node will have the value. What will be the value now? 3, right? Okay, now let's enqueue its left and right children if they exist. So enqueue enqueue left and right children if they exist. So we'll say if node dot left is not equal to null, so that means it has a left child. We'll add it to the queue dot offer node dot left. Okay, in the node we have 3 right now. Now does it have any left child? Yes, 9 is there, right? So 9 will be added to the queue. So 9 is part of the queue now. Similarly, we'll check for right node. If node dot right is not equal to null, dot offer node dot right. Simple, that's it. Okay, now we have one element on the right side also, so that will be added here as well, 20. Now once the for loop is over, that means we have traveled through all the nodes on the current level. Currently the size was only 1, so it will run only once for the level nodes. Once the for loop is over, we'll add this to a part of result. So add the nodes at the current level to the result. So result dot add level nodes, right? So this 3 will be added to list of list. So it is already like this. 3 will be added here. Now loop will run again. Since for loop is over, it will go back to while loop. Is the queue empty? Queue is not empty. It has elements 9 and 20, right? So we'll do the same traversal again. Level size, queue dot size. Size will be 2 now. Earlier the size was 1. Now queue size is 2 since we have 9 and 20. We are doing level nodes is equal to new array list. So it will be destroyed and now it is blank again. For I equal to 0, I less than level size, I plus plus, tree node is equal to queue dot poll. So 9 will get removed from here and it will be added as part of the node. Okay, so now node will hold the value 9. Now level nodes dot add node dot value. So it is holding the node 9, we'll add the value. So 9 will come here. Since it is already as list, 9 will be added here. Okay, now we'll check if 9 has any children. Left not equal to null, false, because there is no left child, there is no right child. The loop will move forward. I equal to 1, I less than level size, yes, level size is 2. Tree node is equal to queue dot poll, so 20 will be removed, it will be added to the node. Now node has the value 20. Node is pointing towards 20. We'll add level nodes dot add node dot value. So 20 will be added here to level nodes 20. We'll check if node dot left is not equal to null. That is true, it has a child left. We'll add it to the queue. So 15 will be added to our queue here. So 15 will come here. Similarly, right child is also not null. So 7 will be added here. This loop will get over. We'll add level nodes to result. 9 and 20 were the level nodes. We'll copy, we'll add them here. Now let's move forward. While queue is empty, no, right? Because now queue has 15 and 7. So we'll say level size equal to queue dot size. Queue dot size will come out to 2. We'll check. Level nodes is equal to new array list. So it will be destroyed. Again, it is blank. Now, for int I equal to 0, I less than level size is 2, I plus plus. Tree node is equal to queue dot poll. So 15 will be removed and it will be added to node. Now node will be pointing towards 15. Level nodes, this list dot add node dot value. So 15 will be added here. It is already list. 15 is added here. Okay. Now we'll check node dot left not equal to null. So 15, does it have any left child? No. Does it have any right child? No. This loop will get over. I is equal to 1, I is less than level size was 2. Node is equal to queue dot poll. So now node will get the value 7 will get removed from the node. Level nodes dot add node dot value. So 7's value will be added to level nodes. Does it have left child? No. Does it have right child? No. This for loop will get over. Result dot add level nodes. So this will be copied from here and added to here. Then again we'll go while queue is not empty. Right now we can see queue is empty, right? So this loop will get over. Once everything is done, we can simply say return result. Let's run it. And we are using the time complexity of O of n, where n is total number of nodes, because we are traversing or reaching each node only once. Okay, let's submit. 88.92. Great. Okay. I hope the problem and the solution was clear to everyone. Please take time and go through this problem statement again. This is a very frequently asked interview question. Okay. That's all from today's video. Thank you everyone. Please like, share and subscribe. And for anything, please let me know in the comment section. Thank you.